A rainstorm in Syracuse started as a light drizzle at 1 o'clock, built up into a heavy rain, and then dropped back down to a drizzle. The rate at which it rained in inches per hour is given by the function, where t represents time in hours since 1 o'clock. The rate of rainfall in Columbia in inches per hour is given by this graph, where t represents time in hours since 1 o'clock. In which city did the rate of rainfall increase for the longer amount of time before beginning to decrease? So in terms of this graph here, before I switch over to Desmos, what we're going to look at is we're looking at where the graph is increasing. And if you notice, it says in which city did the rate. So the average rate of change, again, is slope. So if we take a look at this picture here, this is Columbia, I believe, the rate of rainfall for Columbia. Notice the increments on our graph. It goes 0.25, 0.5, 0.751. So we went up 0.25, and then we went over 1. I'm going by the increments here. Rise over run for slope. Instead of formula, we could have done a formula, but rise 0.25 over 1. So Columbia, that's our slope. If we flip over to Desmos and we type in that function, negative 0.5 times the absolute value of, instead of t, I'm typing in x minus 2 plus 4. So here we get the picture. And what we're looking at on this particular graph, again, is still the rise over run. Well, in this case, the increment is 1, 2, 3, 4, 5. It's an increment of 1 both ways, going up and down, going right and left. So this one we would go up 1 over 2, which is the same as 0.5. So our two slopes, for Columbia, it's 0.25. For Syracuse, it is 0.5. And it says, in which city did the rate of rainfall increase for the longer amount of time before beginning to decrease? And the answer is Syracuse. We had 0.5 for 1 hour compared to 0.25 for 2 hours. 0.5 of an inch for 1 hour compared to 1/4 of an inch for 1 hour.